Well, hello, good people. When we last left our heroes, that's you, they had just learned how to use a two-scale diagram in order to solve a vector problem. Well, today we're going to learn how to use the mathy way to solve a vector problem. In other words, we're going to learn how to use algebra. We're going to start by looking at a totally new problem that you've never seen before. It says an airplane takes off from DIA and travels 430 miles due north before the pilot realizes the plane is off course. To correct the flight pattern, the plane travels 310 miles due east before changing its direction to the correct flight path. How far is the plane from the airport, and what is its heading in degrees north of east when the pilot finally gets the plane on course? Wait for it. And there! Now it's a totally new problem. Because today we are not going to use a protractor and a ruler to solve this problem. We're going to use algebra. Now, the first thing when you do algebra is that you are going to start by creating a sketch. Now, you already created a two-scale diagram, so you do not need to create a sketch of this situation. But I can't have my two-scale diagram here and my sketch here. I don't have enough space on and all my math here. I don't have enough space on my paper. So I recreated a little sketch here that you could see. When you create a sketch, it's very simple. You just create the north, south, east, west axes, or whatever your coordinate axes are for that particular problem. And you draw your three vectors with some lengths that look kind of like about right-ish in the directions that are correct, and that's it. So it's not anything where you're like really seriously taking out your ruler and measuring everything. It's just a quick like, and then you're done. Okay. Once we have a sketch, now our next task is to write down our knowns and unknowns. Now, you know that in any physics class, or any science class, when you begin a science problem, you always complete 5 steps. And the 5 steps are first, to write down your knowns and unknowns, or to write down your givens. The second step is always to write the original equation or to write the formula. The third step is always to algebraically rearrange to solve for what you're looking for. The fourth step is to plug in numbers. And your final step is to plug it into your calculator, solve, and get a final answer. We will follow those 5 steps today. The first step is to write down our givens. So I'm going to do that. I start by writing down vector A. Now, you already know how to write in good vector notation, so I won't tell you that now. But I will tell you that you are definitely going to include units. You're definitely going to include direction here. And you're definitely going to include a vector hat. That is one of our givens is vector A. The next given is vector B. This is only going to take so long as I wait for this to load. Okay. Oh, it's working. You got it, buddy. You can do it. You can do it. You really can do it. Yay. Okay, vector B is 310 miles to the east. And then finally, what we're looking for is vector R. When we look for vector R, the way that we are going to accomplish it, I start by saying that I'm looking for vector R. But the way that we are going to accomplish it is that first we are going to find the magnitude of R, and then after that we are going to find the angle of R. Let's start by finding the magnitude of R. I'm going to write it up here. Find R. Okay. When we find R, I'm looking at this little guy right here and I'm like, oh my goodness, does this not look like a triangle? And does it not furthermore look like a right triangle? We say, wow, that is just fantastic. If we know the length of one edge of a triangle and the other edge of a triangle, then we know we can find the length of the hypotenuse of the triangle using the Pythagorean theorem. Now, a lot of students are tempted here to write a squared plus b squared equals c squared. But I take a little bit of issue with this, and the issue that I take is that this is a very good math statement, but it's not a very good physics statement. And the reason why it's not a very good physics statement is because in physics, the letters actually represent real physical quantities. Now, we have an A in the picture. We have a B in the picture, but we don't have a C in the picture. So to say A squared plus B squared equals C squared is not really an accurate reflection of what we're actually really trying to find. So in physics, we say A squared plus B squared equals R squared. Step 1 is to write your givens. Step 2 is to write your formula, which in our case is the Pythagorean theorem. Step 3 is to rearrange to solve for what you're looking for. We are looking here for r. That's the magnitude of the r vector. To find the magnitude of the r vector, we can algebraically rearrange by square rooting both sides, and we get that r is equal to a squared plus b squared, like this. Then, after that, step 4, we can plug in numbers. Whenever we plug in numbers in this class, you always plug in numbers with units. If you don't plug in your units here, then you will not get full credit on this step. So please make sure that you write 430 miles and 310 miles squared, all under the square root. Finally, for r, when you type this into your calculator, you get 530 miles. Notice, I have good sig figs here, and I have good units here. Some students are tempted to say that this is miles squared, but you'll notice that it's just one line. A mile squared would indicate an area, and it's not an area, it's a singular line. So that looks right to us. Now, I like to circle this answer because it is an important answer, but I don't box this answer because I always box my final answers. So I will circle this answer. If you like to circle little answers along the way, that's fine. But I do ask that you make it very clear what your final answer is, and that's very distinctive from your on the way kind of answers. This is not our final answer because it does not include direction. Sorry, I'm trying to not cross out everything out. You know what? I'm not even going to circle it, okay? Sorry, fine. It just is making it too messy. I can't read everything. But if you want to circle it, then that's totally fine. Again, just don't box it because it's not a final answer, or whatever system that you use to show what your final answer is. Please just make sure that this does not look like your final answer because it's not your final answer because it doesn't have an angle yet. Now, a few notes here. Notice, I don't have vector hats here. 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 And I didn't plug in any direction here. And I don't have a vector hat here. Why? Because I'm only looking for the magnitude of r. This is r without direction. And so because it's r without direction, I don't want vector hats the whole way through. Then after that, we are ready to find theta. Okay, let's do it. Now, normally in class I say, okay, students, which of your trick friends would you like to use to help you find theta? And normally they say, oh, theta isn't, and they struggle because theta isn't trapped inside of a triangle. So they say, I don't really know what to do. Now, fret not because there are options for you. One option is to find this other interior angle here. Wait, I'm just gonna dot. Okay, one option is to find this interior angle here. Let's call it phi. One thing that you could do that looks kind of like a lowercase letter d. Let's try again. Okay. One thing that you could do is you could find phi, then do 90 degrees minus phi, and that will give you this angle theta. If you wanted to find phi, you could use inverse tangent. The reason why we use inverse tangent is because then we're looking at vector B, which is the opposite, and vector A, which is the adjacent. And here, I'll write this down for you. Tangent of phi would equal B over A. So then phi would equal the inverse tangent of B over A. Now, here's why we use tangent and not something else is because we want everything in terms of things that were given and not in terms of numbers that we found. We found the numbers, we found the number for r, but we don't want anything in terms of the hypotenuse, because then if we made a mistake when we were looking for r, then we would carry that mistake through into our calculation of phi, which we do not want to do. So we just use inverse tangent so that our final expression is in terms of things that we were already given. Okay, then if we wanted to find theta, theta would be 90 degrees minus phi. And then we would say that means that theta is equal to 90 degrees minus inverse tangent of B over A. Then we could plug in numbers and get to a final answer. That is one option. Here is another option. Another option is that we could do what I call completing the rectangle. You could draw a little edge here and draw a little edge here to complete your rectangle. And do you agree if I made this into a full rectangle, then the length of this side here would be the same as the length of B. And the length of this side here would be the same as the length of A. And so, now we have trapped theta into a little triangle. If we trap theta into a little triangle, then we see that tangent of theta is now equal to opposite over adjacent, A over B. And then we would say if you want to find theta, you can just take the inverse tangent of both sides. So theta is the inverse tangent of A over B. Then we can plug in numbers and get to a final answer. To plug in numbers here, when we plug in numbers, we always plug them in with units. I plug in 430 miles. Oh, I gotta move my face. Sorry, me. Go up here. Wait, you can do it. Hello? Maybe I can't do it. Okay, well that's super awkward. Then we're just gonna keep on going. 430 miles over 310 miles. Pretend like you can see that whole thing. You'll plug that into your calculator, and when you plug it into your calculator, you'll get something like, I'm trying to remember off the top of my head, and I do believe it's 54 degrees. But I could be wrong. Okay. Actually, I'm going to check because I just want to know. What is the truth? Yeah, 54 degrees. Yes. Okay. Now, I have R and I have a theta. The last thing that I have to do is I have to put them together. To put them together in one final expression, I write it as R hat is equal to 530 miles, 54 degrees, wait for it, 54 degrees, and now I had to define what this angle is. A lot of students ask, wait a second, Miss Wilson, why did you choose that angle for your theta and not this other? Why don't you just use phi instead of theta? Well, because it asks for the heading in degrees north of east. That tells us exactly which angle we're going to pay attention to. North of east means that you start on the east axis and you're going to start heading up north from the east axis until you run into your vector. So if I start at the east axis and I run up towards the north, I go click, 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 until I run up to the east, until I run up this way. That carves out this angle right here. If I were labeling phi, I would start at north and go east of north. So I would call phi the angle east of north. Because I start at north, and to carve out the angle phi, I start at north and I start heading east of there. Click, 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 until I get to vector r. So we are looking at 54 degrees north of east because that's the angle that the problem asked us to find. And then we box up our final answer because this is really, truly, oh gosh, that was a terrible box. Okay, I'm just going to go with it. I'm going with it. North of east. Okay. A few little notes here. If this were a test, I want to show you exactly what you would get points for. You would get, on a test question, you would get a point here for writing out your givens. That's worth a point. When you write out your givens, you have to write out your givens with your number, units, and direction, and the vector hat. You have to write r hat is equal to question mark. You can't just write r is equal to question mark or theta is equal to question mark. You're welcome to add these as well if you would like to, but I don't require them. I do require you, though, to write r hat equals question mark because that is actually what you're looking for. Then you get a point for writing an original equation here. That is the original formula for the Pythagorean theorem. You get a point for rearranging the Pythagorean theorem. You get a point for then plugging in numbers here. And then you would get a point for a final correct answer for r. When you plug in numbers back in step 4, please make sure that you have units, otherwise you would lose this point. Then, when you find theta, you get a point for some expression for theta, either inverse tangent of a over b or 90 degrees minus inverse tangent of b over a. Either one of those works okay, and either one of those will get you the point. Then you get a point for plugging in numbers to either this expression or this expression, whichever one your heart desires. You get a point for a final correct answer for theta. Then you get a point for putting it all together as one statement for the vector r. You get a point for correctly identifying this as north of east, and then I can't quite remember here if it's 1 point for sig figs or 2 points for sig figs in units, but it's a 1 or 2 points, either like 1 point here and 1 point here, or like 1 point for both of them. But there's 1 or 2 points for sig figs in units here. And then you also additionally get a point for having good vector hats and direction everywhere where you're supposed to have it, meaning having good vector hats and direction over here. And then also for not having vector hats and direction where you don't need it. So for not having any vector hats here, for not having any vector hats here. So, oh, and then there's one bonus sneaky point that you sometimes get. If you had to draw a sketch, then you get a point for drawing a sketch. But if you already drew a 2-scale diagram, then you don't need this point here. So this point depends on what other work you've done. So on a test, this question would be worth about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-ish points. 12, 13, 14, somewhere in that general range. Okay, that's the first problem. Let's go ahead and take a look at another one. Okay, that's like my version of Jeopardy music. Okay. A monkey leaves his favorite tree and walks 62 meters due east and then 45 meters due south to reach his favorite lunch spot. So fun. What is the displacement, the distance and direction with respect to due east from the base of his tree to his lunch? Okay, first I draw a little sketch here. You'll notice that I've already labeled this interior angle as theta. The reason why I chose that angle as theta is because it asked for the direction with respect to due east, which means I have to start at the east axis and then carve out from the east axis. If I start at the east axis and I carve out towards R, then I get this little angle right here. Do you see if I started over here and I tried to carve out this angle, I'd be starting on my south axis and carving towards R. And so that is not with respect to due east. It's not even touching the east axis over here. And so this is the little angle that we want to go with. The first thing that we do is we write out our knowns and our unknowns. Okay, here we go. We were given vector A is 62 meters east. Then we were given that vector B is 45 meters south. Oh gosh, how did I not even change that color just now? Purple. So that I can match my picture. Okay. B is 45 meters south. Then what we are looking for is we are looking for vector R. And to find vector R, we're going to need to find both the magnitude of R and also the angle of R. Okay, we are going to start here by finding R. Come on, team. You can do it. Change the color. Let's go. Yes. You got it. You can do it. Yes. Come on. Here we go. We're going to start by finding... Oh, no. I hate when it does that. Deep sigh. Okay. Team. Okay. Find R. To find the magnitude of R, we start with the Pythagorean theorem. We say a squared plus b squared is equal to r squared. Then we rearrange to solve for r. When we do, we get r is equal to the square root of a squared plus b squared. Then we can plug in numbers. When we plug in numbers, of course, we always plug them in with units. We write that r squared is equal to the square root of a squared, which is 62 meters squared, plus b squared, which is 45 meters squared. Then we can plug that into our calculator, and when we do, we get 77 meters. Next step is to find theta. When we find theta, here we are going to use opposite here, B, and adjacent here, that's A. We're going to use inverse tangent. So we say that theta is equal to inverse tangent of B over A. Notice this time that theta is tucked inside the triangle, so we don't have to do anything funky with phi or with completing the rectangle. We are all good to go. Now, we can plug in numbers here. We do inverse tangent of B is 45 meters over A, which is 62 meters. Plug that into our calculator, and we get 36 degrees. Then we can write R all together. R hat is equal to 77 meters, 36 degrees. And now let's be careful about how we define our angle. We started at east and we went click, 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 click towards the south until we ended at R. So we're going to go south of east. And that is our final expression. Now, one other comment here. One thing that you will always do for me when you do work in physics class is you will always do all of your work vertically. Notice, I have my knowns and unknowns over here, my givens. If you want to do those on like one horizontal line, I'm fine with that. I like to stack them vertically, but however you like to stack them is fine. If you want to put them all on one line, that's fine with me. But then after that, each step gets its own line. So this step, a squared plus b squared equals r squared, takes up its own line. I don't then draw a little arrow to the side and then write r equals the square root of all of this. No, I go down to the next line. And then when it's time to plug in numbers, I go down to the next line. And then when it's time to get a final answer, I go down to the next line. Same thing here. I start with an expression. I go down to the next line to plug in numbers and down to the next line to get my final answer. And so this whole way through, I am going line by line by line and showing all of my work vertically. Thanks, DJ. I'm going line by line by line and showing all of my work vertically until I get to a final expression. And really, this should kind of be down at the bottom of my work, but I don't really have space for it on there, so I put it up over here. And ladies and gents, that is pretty much all of it for today. Thanks so much for watching this video about how to do the mathy way. Before you go, I would take a moment and pause and think, what are some of the advantages and disadvantages of the mathy way? What are some of the advantages and disadvantages of the diagram way? They both have their own strengths and weaknesses, their own pros and cons. And different methods are useful for different situations. You will be expected to know how to do both. And that's all for today, folks. I hope you have a wonderful rest of your day. Bye, good people.